All right, so in this example, we have a solid. In the base of the solid is the region in the xy plane bound by the graph x squared plus y squared equals 9. So we should recognize this as an equation of a circle. All right. Find the volume of a solid if every cross section by a plane that's perpendicular to the x-axis is an equilateral triangle with base in the plane. So the base is going to be underneath the function. So there's a couple different things going on here. So let's go ahead and draw our picture. So here is the graph of x squared plus y squared equals 9. So we're going to draw a circle. Okay, so remember, this over here is our r squared value, so the r is going to be 3. So we have a radius of 3. So we're at 3 and -3 on the x, because we are perpendicular to the x-axis, so we want the domain. Now we need to identify what our area function is. So area of an equilateral triangle, it's the same thing as any other triangle, so 1/2 base times height. All right, so now we have the area. Now we need to identify what the b and the h are. So this is where the challenge comes in. So we know that a circle is not a function because it has two different y values for your x's. So what we need to do, and we know we have to be in terms of x, we have to solve this. Okay, we have to solve this for y. So if we do that, it's going to be y equals the square root of 9 minus x squared. That is the function that we're dealing with. Okay, so keep in mind, this function is the top part of this circle. Okay, so we have a semicircle here. So we have to remember that when we're trying to find our b and our h. So if we have a b value, so the base, remember that's in the function. So if I were to draw an equilateral triangle, so here is one of the sides, and then the other sides. So I'm just going to draw it coming out at us. And we know all three of those sides are the same length. So let's think about this. If I draw one of the sides in the entire length of the circle, okay, this function, our root of 9 minus x squared, that only shows us half. That's this part right here. Okay, that is our function after we solved for y. So to get the base, I need to multiply our function by 2. Okay, and this is probably one of the hardest situations that you're going to deal with. There's a couple more that we will look at, but this is definitely one of them. So 2 times the function. So 9 minus x squared. So hopefully you can see that. Now we need to figure out h. So this, again, is a little challenging, especially if we have a hard time remembering our trig. So what I want to do is I'm going to draw a triangle that is equilateral. So we know that these angles are always, that's 60 degrees, all three of them, right? Because 3 times 60 is 180. So we have an equilateral triangle. We know that this distance, the one of the side lengths, is going to be twice the function length. So now I need the height. So the height goes right down the middle. This is our height right here. Right? Perpendicular bisector. Here's a 90-degree angle. So how do we find that height? Well, talked about it 2 years ago in trig, and you would have done it in geometry. So if I draw half of our equilateral triangle, so we're bisecting one of the sides, so that is going to be 9, the square root of 9 minus x squared. We have a 90 here, we have our 60 here, and then we cut this 60 degrees in half, so that's going to be 30. So this is a special right triangle that we've used many times throughout the last couple years. So 30, 60, 90 triangle, in general, I'm just going to draw it over here. We have a side ratio, so short side, that's across from the 30. Hypotenuse is double that, and then our medium side is always root 3. Okay. So 1, and I want to know the medium side. I want to know the side across from the 60. So that is root 3 times our short side. So that length right here is our function times root 3. Okay, so I know I'm throwing a lot at you in this problem. That's why I wanted to make a separate video. So we should have all of our pieces of information that we need. So now the h value we just found, h value is the root 3 times our function. Okay, so now I have all my variables known. Now we can go ahead and set up the integral. So if we come down here and set the integral up, we have 1/2 base times height for our area function. So I'm going to take the 1/2 out front. Base times height, so we already have the b and the h, so just plug them in. So we have this times our height. So here's the setup. So we can go ahead and simplify this a little bit. And just out of habit, I took the constant to the front, and I didn't really need to in this case because the 1/2 and the 2 will cancel out. A square root multiplied by itself is what's inside. So this cleans up to be root 3. Actually, I'm going to take that out front. The root 3 will jump out front. And we're just left with 9 minus x squared on the inside. Now we need to talk our boundaries. It's usually one of the first things I do, but I wanted to come back to this. So keep in mind, we are going this entire distance. We're taking a bunch of equilateral triangles underneath the entire function. So the function, its domain would be -3 to 3. So that is going to be our boundaries. Okay, go ahead and integrate. Take your 3 and your -3, evaluate them, find the difference, and then that's it. So I will try to make another video on another more challenging setup, but that is it. Let me know if you have any questions.